Hi, my name is Jacob.
My name's Caden.
I'm Michelle. And I'm Hannah. We are Hagrid's henchmen, and this is our evaluation report.
As you all know, that 2110 competition is based on the movie Fantastic Beasts: Crimes of Grindelwald. The task is simple. We must expel a Dementor,
Expecto Patronum!
separate a Niffler and its gems, imprison the Dark Wizard Grindelwald, and egress from Azkaban, all under 40 seconds. Our machine will compete on the 7x7 foot track shown here, where each colored triangle is a team's home zone. The points for each task are as follows: -13 points for each Dementor in your zone, -10 points for each Niffler in your zone, +4 points for each shiny object, and +15 whole points for imprisoning Grindelwald and egressing successfully. A successful egress will also double the shiny object score.
The most important customer requirements on our House of Quality include coinciding the machine start with the track start, reaching all parts of the track, especially Azkaban, and sensing the opening of the Azkaban gates. The most important engineering requirements include that all functions must be programmed, the machine start must coincide with the track start, and all of the measurements that correspond to the maximum dimensions and machine reach. In addition to meeting these requirements, our machine must also perform a variety of functions shown in our function tree.
Our machine is competing to save the world from Grindelwald, but in order to accomplish this, we have defined several sub-functions that need to be addressed in our design. We believe the most difficult sub-functions are those that involve the intervention of other teams, specifically removing the Nifflers, reaching Azkaban, and sensing the opening gates. While other teams remove Nifflers from their zones, we must prevent them from putting any in our own. Sensing the opening of the gates and reaching Azkaban before the other teams will also be a challenge, because only one team will be able to drop Grindelwald in Azkaban.
The Nimbus 3000 is a compilation of all the best parts from each of the alternative machines. Reach is achieved with drawer slides holding onto a container. The Dementor is retrieved with a hook located under the container that flips out during egress. Nifflers and shiny objects are sorted and ejected within the box. Then a scissor arm extends to reach the prison and deposit Grindelwald. Egress is accomplished using a brushless motor attached to a spool and paracord. Overall, the machine is fast, accurate, and consistent compared to the other designs.
The entries in the morph chart were used in the alternative and final designs. Through the evaluation of the alternative designs, we were able to see which morph chart entries were optimal. The drawer slides proved to be a superior method of extending the machine to Azkaban and will be used in the final design.
Flap-the-Mat is a simple, lightweight, and cheap design that is also easy to code. Its disadvantages are that it's inaccurate and unreliable with placement of the 3 arms. Advantages used in the final design are the use of pneumatics, as they are powerful and quick enough to move the system effectively.
Daddy Longarm is a compact package that uses drawer slides to reach the edge of Azkaban so that it can accomplish all of its necessary tasks. A filter with an extended arm is used to move the Nifflers and shiny objects out of their slots so that they can be rejected or collected. As soon as the IR sensor detects that the gates have dropped, Grindelwald is slammed into prison. Kobe! And the Dementor is removed during the egression of the drawer slides. The overall device works very quickly, however, the machine requires a lot of setup before it can begin operation.
Upon activation of the Slide and Hook 250 machine, drawer slides shoot out by solenoid-controlled mouse traps. To expel the Dementor, the machine uses an L-shaped wood piece to pick up the Dementor during the egress. To separate the Nifflers and shiny objects, a hook arm channels the gems and Nifflers into a separating filter. To imprison Grindelwald, scissor arms will extend to reach the top of Azkaban with a bowl and flipper. To egress, one motor will retract the scissor arms and the other will retract the drawer slides in a winding fashion. The pros include the use of the drawer slides to extend to Azkaban for efficient movement, which will be used in our final design. However, the design cannot prevent from other teams putting objects in our zone.
The freewheeler shoots out with pneumatic pistons and rolls all the way up to Azkaban. It is equipped with a filter that flips out to capture Nifflers and shiny objects and an arm to deposit Grindelwald. A major downfall of this design is its inaccuracy after shooting out. We used the pneumatic pistons to shoot out our final design, but added drawer slides for accuracy. As the third level evaluation matrix shows, the final design is the best design, demonstrated by its high total relative to the others. As you can see, the designs with the second highest totals are the Daddy Longarm and the Freewheeler, which is why more components from these designs were incorporated into the final design.
All of the design tools played a role in coming to our final design. The House of Quality and Function tree provided a clear layout of the competition tasks for prioritization. The evaluation matrices allowed us to quantifiably compare the alternative designs and see what aspects of them would be most useful to include in the final design.